Question 3a. A ball with mass, m, is launched at a speed, v, at an angle, theta, to the horizontal, as shown. The projectile lands at the same height that it was launched from. The horizontal distance traveled, d, is maximum when theta equals 45 degrees. By considering components of the velocity, v, show that the maximum horizontal distance traveled, d, is given by d equals v squared over g. Assume that drag is negligible for this part question. Let's first analyze the vertical motion. Final velocity equals initial velocity plus acceleration times time. The initial velocity equals v sine theta. Final velocity at the top of the trajectory is 0. Acceleration equals negative g, and the time taken to reach the top times 2 equals the total flight time. Substituting these values in, we get 0 equals v sine theta minus gt. Rearranging this, we get time taken to reach the top equals v sine theta over g. Since this is time taken to reach the top, the total time is double this. Since there is no acceleration in the horizontal, d equals vt. The horizontal velocity equals v cosine theta. Substituting the time for the full motion and our horizontal velocity into d equals vt, we get that the horizontal displacement equals v cosine theta times 2v sine theta over g. Rearranging and substituting 2 sine theta cosine theta equals sine 2 theta, and substituting theta equals 45. We get what we are trying to find. Question 3b. A more accurate model of the situation includes a drag force, F, that acts on the ball. This force changes the motion of the ball as it moves through the air. A simple assumption would be that the drag force, F, is constant in magnitude and acts only in the horizontal direction as the ball moves through the air as shown. Show that in the case of a constant horizontal drag force, F, the horizontal distance traveled, d, by a ball launched at speed, v, at an angle, theta, to the horizontal, is given by the expression d equals v squared over g times sine 2 theta minus 2f sine squared theta over mg. We can use d equals vit plus half at squared for the horizontal motion, since there is now a constant drag force. Newton's second law tells us F equals ma. Rearranging this gives us a equals F over m. Since the force is acting in the opposite direction of motion, a equals negative F over m. In question 3a, we found that time equals 2v sine theta over g. Substituting these values in and rearranging, we get what we're trying to find. Question 3c. Discuss the validity of the assumptions about the drag force in part B. Describe more realistic assumptions about the drag force and explain how these affect the horizontal distance traveled by the ball. More realistic assumptions are that the direction of the drag force is always directly opposite to the direction of motion, and that the size of the drag force depends on velocity. This means that the ball will have a larger downwards acceleration on the way up, due to the drag having a downwards component. Therefore, the ball will reach a lower max height, and the flight time will be less. This will reduce the horizontal distance. The drag also has a horizontal component, which will act to reduce the horizontal velocity. This drag force component will reduce compared to a constant force. Question 3d. After receiving an initial push, the solid ball begins rolling up a slope, as shown on the right. The ball has mass m, radius r, and moment of inertia I equals 2/5 m r squared. When it is at height equals 0, the center mass of the ball has velocity vi. When it has reached height equals h, the center mass of the ball has velocity v. Assuming that drag is negligible in this situation, show that the velocity of the center mass of the ball, v, when it has reached height, h, is given by v equals square root of vi squared minus 10gh over 7. Initial energy equals final energy. Initially at the bottom, there was linear kinetic energy and rotational kinetic energy. At the top, there is linear kinetic energy, rotational kinetic energy, and gravitational potential energy. Angular velocity equals v over r. Substituting angular velocity equals v over r and I equals 2/5 m r squared into initial energy, and simplifying, we get initial energy equals 7/10 mv initial squared. Doing the same for final energy, we get 7/10 mv squared plus mgh. Equating these and rearranging gives us what we're trying to find. Question d. Give an expression for the maximum height reached by the ball as it rolls up the ramp. Maximum height is reached when v equals 0. Substituting v equals 0 into the equation found in question di and rearranging, we get maximum height reached equals 7 times initial velocity squared over 10g.